Hey everyone, this lecture is going to be on metric system and dimensional analysis. Now, in science or in life in general, there's many different units you can use to measure the following things: weight, length, and volume. So things that are often used to measure weight or mass can be like in the US, we use pounds, you can use grams, kilograms. For length, in the US, we often use feet or miles if we're talking about like the distance of a trip. And in other places in the world, they often use kilometers. And then for volume, we often use liters to measure like how much soda there is in a soda bottle. You can use milliliters. You can also use cubic meters. So there's a bunch of different ways that you can measure these things, but in science, we're going to use specifically the metric system. Now, before we get to that, let's just simplify the following mathematical terms. So if you can do these following mathematical operations, then you're going to be completely fine in this section. So if you have x over xy, then obviously the x's will cancel out. So you're just left with 1 over y. Okay, and then over here, this is pretty much the same exact thing, where if you have a letter or a number outside of a parentheses, so the parentheses means multiplication, and basically if a number doesn't have a denominator that's showing, it's the same thing as if you wrote this as a over 1. So what this is actually saying is a over 1 times b over a, and again, top and bottom cancel out, so a is on the numerator and a is also on the denominator, so they cancel out. So you would just have b over 1, which is the same thing as b. So if that math made sense to you, then you should be completely fine in this section. Now, going back to the metric system. So again, other countries besides the US use the metric system as their primary system of measurement. So for example, if in the US you would call yourself as I'm 5'8", so 5 feet and 8 inches. Elsewhere in the world, that person would say I'm 172 centimeters. And the reason why the metric system is so useful is because it's based on powers of tens. So for example, in the US, if you have 12 inches, that's the same thing as 1 foot. Or 1 mile is the same thing as 5,280 feet. And even though we know from common knowledge that 12 inches is equal to 1 foot, we just had to completely memorize it. There's not really like a system or a pattern. It's pure memorization. But elsewhere, when you use the metric system, everything is by powers of 10. So 10, this should say decimeters. So 10 decimeters would equal 1 meter. Or 1,000 meters would equal 1 kilometer. It's always by tens or hundreds, 1,000, 10,000, etc. Now, the base units for the metric system are meters, grams, and liters. So meters obviously measures your length. Grams obviously measures your mass, and mass is a little bit different than weight. If you take physics, you'll get more into it, but mass is the amount of matter or stuff that you have. And then your volume is going to be measured in liters. And that's the amount of three-dimensional space something takes up. So how much space does a given object or liquid occupy? Now, in chem, we often use liters or milliliters to measure the volume, but we can also use cubic centimeters sometimes for volume. So if that ever confuses you, there's this one common conversion factor. So a milliliter is always equal to 1 centimeters cubed. So they're kind of synonymous. So if that ever confuses you, just know whenever you see centimeters cubed, it means the same thing as 1 milliliter in chemistry. Okay, so let's get to our prefixes. Now, prefixes are letters that we add to the beginning of our base unit to tell us how much of that base unit that we have. So for example, here we have all of our prefixes. So kilo, hecto, deca, and then your base units have no prefix. And then we have deci, centi, milli, and micro. Now the ones you should memorize for this class are kilo, you should know. Obviously the base units you need to know, meters, grams, and liters. Deci, centi, milli, and then if you get to AP chemistry, you should know micro. Okay, but most of the time they'll be given to you. So what these base units mean is that, let's say you had a meter. So a meter just has no prefix in the front. So there's nothing multiplied against it. But let's say you had a kilometer, that means you would have 1,000 meters. You could do it the other way too. So let's say you had a meter. So again, meter just means one, which means you only have one of that thing. And then if you had a centimeter, you would have 0.01 meters. Okay, so centimeters are smaller, kilometers are bigger. And you could do that with any of the base units. So the same thing applies for, let's say you had a gram. And if you have a decagram, then you would have 10 grams. Or if you had a milligram, you would have 0.001 grams. Okay, now the reason why we need to know this, and again, these will be given to you, but you should memorize the ones I've asterisked. So we're going to undergo this operation called dimensional analysis. And dimensional analysis, all it means is to convert between units. The reason why it's called dimensional analysis is units is synonymous with the word dimension. And analysis just means that you're analyzing which unit you want to change to. So dimensional analysis uses these values called conversion factors. And conversion factors are values that are equal to each other but have different units. So again, they're equal to each other but have different units. So common conversion factors that you should know are 12 inches is equal to 1 foot. So again, what that means is inches is a unit. So if you have 12 inches, it's equal to a different unit, a foot. Okay, another example would be 1 kilogram is equal to 1,000 grams. That's another conversion factor. So conversion factors are always equal to each other. They just have different units. Now there's two ways you can write conversion factors. They're either written like this, when they're like set apart equal to each other, or you can write them as a fraction, and it means the same thing. So 12 inches equals 1 foot, or you could write 12 inches per foot. Again, the 1 is not included here, so it's not written like 12 inches over 1. It's not really written like this because anytime you have a 1 in the denominator, it goes away. So same thing, 1 kilogram is equal to 1,000 grams, or you could write it as 1,000 grams per 1 kilogram. Okay, so let's go over these metric conversion factors, and you might have to memorize this for AP Chem, but for my class, I'll always give you this and this if you need it. Technically, you only need one column because even though meters, grams, and liters, the base units are different, the scale at which they change to should always be the same. So for example, like 1,000 kilograms is equal to 1,000 meters, but if you had 1,000 or 1 kilogram, that would also equal 1,000 grams. So the prefix will tell you how many of each you have. Okay, and these conversion factors, you're going to be using it to do the following problems. So these are the steps for the dimensional analysis calculations, but I'm just going to kind of show you how to do it, and you should be able to figure it out from there. Okay, so let's go over these examples. It says if a road trip is 125,000 meters, how many kilometers is the trip? So whenever you do any type of problem in chemistry or math, the first thing you always should do is circle or write down your starting amount. So in this case, my 125,000 meters, that's my starting amount. And almost all the time, whenever you do a calculation, you're going to write your starting amount first. So I'm going to write down my starting amount. So 125,000 meters. And then I'm going to multiply an empty fraction next to it. So I like to use parentheses as multiplication. If you want to write it like this, so you put the multiplication sign and a fraction bar, you can, but I just always use parentheses. Okay, so I'm going to write 125,000 meters multiplied by an empty fraction bar. Now, in this problem, it's asking me to change from meters to kilometers, right? I have 125,000 meters. How many kilometers is a trip? So what you want to do is you want to write down your conversion factor. So go back to your conversion chart and look wherever it talks about meters and kilometers. So if I look, it talks about it right here. So my conversion factor would be 1 kilometer is equal to 1,000 meters. Okay, that's the conversion factor that I'm going to use. Now, the next step says write in the same unit as the starting unit on the opposite side of the fraction bar. Okay, so what does that mean? So I have meters here, and you want to cancel out meters and change it to kilometers. So remember back from up here, if you have a unit or a letter or variable on the numerator and the denominator, they cancel out. So that's the same idea that we want to apply over here. We want to cancel out our meters. So over here on our starting amount, it's written on the numerator. So to cancel it out, we would have to write our meters on the denominator. Okay, and then we write the unit that we want to change to on the top. So it's asking for how many kilometers is the trip, so we would write kilometers on the top. Okay, and then we're going to place our numbers based on our conversion factor. So based on our conversion factor over here, we would have 1 kilometer for every 1,000 meters. Okay, so if you look, your meters will cancel out, so I'm going to cross them out, and I would have 125,000 times 1 kilometer over 1,000. So you can put that into your calculator. I'll just show you over here. So I would have 125,000, and then you can use, times 1 kilometer. So it was 1 kilometer over 1,000. So divided by 1,000. So I would get 125. So my answer would be 125 kilometers. Okay, and make sure you always write in your units, because in chem you have to have your units, or else you're not going to know what number to use, or you're not going to know what you're talking about. So always make sure you write your units. All right, let's go to the next example. So how many inches are in 252 feet? Again, whatever your starting amount is, you're going to write it on top. So this is 252 feet. And my conversion factor in this case is I want to go from feet to inches. So you should know this off the top of your head, right? You would have 1 foot is equal to 12 inches. So again, since you want to change feet to inches, you want to cancel out feet. So over here on our starting amount, it's in the numerator. So you want feet on the denominator here. And you want to change to inches, so you will put inches on the top. Okay, and then substitute in your numbers from your conversion factor. So you have 1 foot for every 12 inches. And your feet are going to cancel out. So feet cancel out. Because numerator and denominator, they cancel out. So you would have 252 times 12. So if you put that in your calculator, you should get 3024 inches. So 252 times 12. Yep, 3024. So all you're doing is really, you're just converting units. Okay, so this problem here is going to be a little bit more complicated. Now, in this problem here, it's asking for us to change from 9,000 centimeters to kilometers. Now, the only problem is if you look at our conversion factors, we don't have a direct conversion from centimeters to kilometers. We have kilometers to meters over here. We also have centimeters to meters over here. So what you're going to have to do is you're going to have to do a two-step problem. You're going to need to change from centimeters to meters, and then from meters to kilometers. So if you look over here, our starting amount is 9,000 centimeters. So I'm going to write that on the outside and multiply my empty fraction bar. And then we need to figure out what conversion factors we're going to use. So again, like I was saying, we can change from centimeters to meters. And then we can change from meters to kilometers. So 2 conversion factors that we're going to use. So centimeters to meters is right here. You have 100 centimeters is equal to 1 meter. And then for meters to kilometers is right here. You have 1 kilometer is equal to 1,000 meters. Okay, so let's change from centimeters to meters first. So I wrote my starting amount. I'm going to cancel out centimeters and change to meters on the top. And if I look at my conversion factor, you have a 100 centimeters for every 1 meter. So your centimeters are going to cancel out. And this should give you, if you put it in your calculator or do it in your head, 90 meters. Okay, now that I have 90 meters, that's going to be my new starting amount. And I want to cancel out meters, so I would put meters on the bottom. And I want to change to kilometers, so I would put kilometers on the top. So my meters would cancel out. And then if I look at my conversion factor, I have 1 kilometer for every 1,000 meters. So 90 divided by 1,000, that would give me 0.09 kilometers.